India's Chandrayaan-3 moon mission has already proven historic. It put India in the history books for being the 4th nation to ever successfully land a spacecraft on the moon, and the very first to ever land at its south pole. The lander Vikram and the rover Pragyan already made discoveries that could profoundly impact our understanding of the moon's chemical composition and geological history, and has given the world vital data that will aid future return missions to our lunar neighbour. And yet, for all the praise, which is well deserved, it's what Chandrayaan-3 did not discover, but should have, that I find the most intriguing. Have you noticed it too? India's NASA equivalent, ISRO, the Indian Space Research Organisation, made press releases before the launch, and there was always one thing they claimed they were primarily there to find. One reason the South Pole was picked out over all other locations. One mystery about the moon that is deepening the more we investigate, and yet needs to be solved before we can expect to start setting up permanent bases up there. Simply put, where is all the water? I'm Alex McColgan and you're watching Astrum, and today we'll take a look at Chandrayaan-3, explore its successes, and attempt to use its discoveries to answer that one important question. It was India's Chandrayaan-1 mission that helped provide some of the clearest proof that the moon's polar craters might hold water ice. Water on the moon had been hypothesized since the 1960s, and in 1971, Apollo 14 found some traces of water vapor at the lunar surface. But water ice itself proved difficult to pin down. Scientists thought that if water ice was anywhere, it would be in the craters at the north and the south lunar poles. These craters were aligned such that they never received direct sunlight, and thus were very cold, some of the coldest places in our entire solar system. The perfect forming ground for ice. Sadly, images of these crater cold traps were too low resolution, or simply too dark for us to know for sure, and while there were numerous detections of hydrogen on the moon's surface, it was unclear whether this took the form of actual water ice or not. However, in 2009, signs of hydration began to emerge. Chandrayaan-1, carrying a NASA Moon Mineralogy Mapper, found the first definitive spectrographic signatures of water ice in dozens of craters congregated around the moon's poles. This water map was later confirmed by Chandrayaan-2, leaving scientists increasingly confident that there was potentially 600 million metric tons of water ice to be found in the moon's darkened craters. Water on the moon is a big deal. More and more nations have goals of setting up bases on the moon, and being able to source your water from the moon's surface saves you from having to spend huge amounts of resources getting it up there. Water is vital for human life, but also could be broken down for hydrogen and oxygen, useful ingredients for rocket fuel, or a breathable atmosphere in your moon base. So it should come as no surprise that when Chandrayaan-3 began to make its way towards the moon, one of the things the media reported it was hoping to find was water ice. Chandrayaan-3 was launched on the 14th of July 2023. It was made up of a lander module called Vikram, a small rover called Pragyan, and an orbiter module that carried the other two components across the Gulf of Space. On the 23rd of August, Vikram, with the little Pragyan tucked inside, touched down on the moon's surface at the beginning of a lunar day. But time was not on their side. Chandrayaan-3 was a surprisingly cost-effective mission. While NASA's Artemis mission launches will each cost on average $4.1 billion, the entire Chandrayaan-3 mission only came to 6.15 billion rupees, or about $75 million, ironically less than what many modern blockbuster space films take to produce. Perhaps Hollywood should consider filming their next moon film on site. However, with this lower budget came technological limitations. When the lunar night fell, Vikram and Pragyan would be subjected to temperatures of minus 120 degrees Celsius, temperatures they were not designed to survive. A lunar day lasts 14 Earth days. The Chandrayaan-3 mission would need to complete its major objectives in that time, as their odds of surviving to the day after that were slim. And so Vikram lowered its ramp, and Pragyan, the rover, powered up and headed out down onto the moon's surface. Pragyan is a 27 kilogram, 6-wheeled rover that came equipped with an alpha particle X-ray spectrometer for analyzing the chemical composition of the moon by firing radiation at it and seeing what wavelengths bounce back, and a laser-induced breakdown spectroscopy instrument that does a similar thing, but this time by firing a laser at the target of interest and analyzing the light wavelengths that are released by the resulting plasma. These two tools together would be enough for Pragyan to attempt to find water or any other interesting substances, confirming their composition for scientists once and for all. And so it set to work, deploying both instruments on the ground next to it. Within days, the results started to come in. Aluminium, calcium, iron, chromium, and titanium were all found on the moon's surface, along with other interesting elements like oxygen. Indian scientists were most excited at the first ever in situ measurement of sulfur at the moon's pole. Sulfur is an exciting element to find, as it helps us understand the evolution of the moon over time, and indicates there used to be volcanic activity in the region. But in spite of all these discoveries, there was one element that was not showing up in the analysis. The all-important hydrogen was notably absent. Pragyan set off to explore further afield. Guiding the rover was all done manually by scientists back on Earth, looking through Pragyan's onboard navigation camera. This had to be carefully done, as the signal delay between Earth and the moon meant that orders for the rover to halt lagged by a little under 3 seconds, time that might make all the difference if the little 6-wheeled rover was to avoid overturning. And indeed, this nearly happened. Early on in Pragyan's journey, the rover had to speedily stop to avoid falling into a large 4-meter crater scientists hadn't initially realized was there. I say speedily. Pragyan's move speed was 1 centimeter per second, hardly the fastest of sprinters. Over the course of its 2-week life, Pragyan traveled no more than 100 meters from Vikram. Fortunately, the crater was detected in time, and scientists were able to turn around and choose another route. However, when you look at Pragyan's route, you notice that there was a second moment where Pragyan did not travel down into a crater it came across, instead electing to go around. No photos of this second crater are currently available, so we are left to conclude that no ice was spotted there. Vikram itself did not remain idle during this time. It performed temperature readings of the moon's surface, digging 10 centimeters deep to measure the moon's warmth at different depths. It measured the plasma content of the atmosphere. Good news, there's not much up there, so radio communication to the moon likely won't get much interference. It detected a possible moonquake, which, given the small 2-week window, was some excellent timing. At the very end of its journey, in a moment of final enthusiasm, the Vikram lander even successfully performed a 40 centimeter high hop, firing its boosters to lift itself off the ground, moving 30 to 40 centimeters along from its previous destination. Indian scientists had wanted to test how easy it would be for future landers to one day propel themselves back into orbit from the moon, and this was a useful practice run. But none of this helped the Chandrayaan-3 mission to find water ice. By the 4th of September, time was up. Vikram and Pragyan were ordered to power down. ISRO scientists had hoped to wake them up again once the night ended, but this hope proved to be fruitless. The 2 lunar explorers had communicated with Earth for the last time. ISRO and the scientific community at large lauded their efforts and called the mission a success, and indeed it was, as India had gained first-hand data from the moon that would be extremely helpful in building a picture of conditions at its poles, along with furthering our understanding of the moon's history. However, it definitely raises a mystery. When I first heard that water ice had been detected on the moon, I envisioned in my mind frozen ice lakes, or possibly tall penitentes. Perhaps a light frost, as vapor from the moon's atmosphere ended up trapped in these darkened craters, freezing over the surface and building up over time. We know from orbiters like Chandrayaan-1 that water ice is indeed in these craters, and yet Chandrayaan-3 has joined other missions in failing to actually see this ice for themselves. I remember feeling similarly disappointed when I first saw the images captured by ShadowCam, a NASA camera carried on the South Korean Danuri moon orbiter. ShadowCam was so good at detecting light, it could see into the polar craters that hadn't seen direct sunlight in millions of years without issue. And yet, once again, there was nothing there. Nothing but arid dust. Given that Pragyan's analysis of the lunar regolith revealed no signs of water molecules, where is the water ice that Chandrayaan-1 detected? While this mystery is confusing, Chandrayaan-3 offers us a possible answer. Not through Pragyan's explorations, it's actually Vikram that possibly hinted at the solution. When Vikram used its chased temperature sensor, it was able to take 10 different readings of the moon's temperature, starting at the surface and working its way down in 1 centimeter increments. What it found in the space above the moon's surface was a temperature a little under 60 degrees Celsius. Definitely too hot for you to walk around in if you happen to be on the moon and somehow didn't care about the lack of air. But curiously, as Chase measured deeper and deeper beneath the surface, this sweltering temperature dropped off fast. By 8 centimeters deep, the new temperature Vikram was detecting was minus 10 degrees Celsius. That's a big drop. From this we can see that lunar regolith is a really poor heat conductor. But that also indicates quite clearly that the best place we're likely to see ice is not resting on the moon's surface, but we actually need to look beneath it. There's much we don't understand about the moon and its water cycles. There's growing evidence that the moon contains quite a lot of water, and yet extracting it will take understanding where that water can be found, and how it moves throughout the long lunar days and nights. Is it affected by solar radiation? Is it trapped in hidden deposits? Although Chandrayaan-3 only lasted 2 weeks, which I'm sure is less time than ISRO scientists would have liked, it has offered us vital insights into the conditions on the moon. As far as water is concerned, at the very least, it has given future astronauts this one piece of advice. If you want to find a drink of water on the moon, you might want to start by bringing a shovel. Preserving the beauty of space is something I am passionate about. I love the planets and moons of our solar system. Each has a distinct personality and houses incredible vistas. Do you have a favorite? Let me know in the comments what your favorite is. Mine is Earth, and I have captured its awe-inspiring beauty and hung it on my wall with my display collection. I've made designs for these unique metal posters in 2 different styles for 11 different objects in our solar system, and I really love how each of them has turned out. You can see zoomed in planet horizons or full planetary disks and their accompanying moons, all based on real imagery where it was available. Maybe you will love it and want it for your home, but equally it can be a great gift for someone who loves space. If you're interested in supporting the channel and owning an Astrum display, then follow the link in the description below for a 20% discount on your next purchase. Go check it out. Thanks for watching, and thanks to my patrons and members for your support. If you want to support too, check the links in the description below. All the best, and see you next time.